Welcome to session 5 of chapter 1. Organic chemistry. We were dealing with alkenes and dienes. We have in our previous session seen nomenclature and classification along with synthesis of dienes. In this session, we are going to see addition of HBr to butadiene with mechanism and Diel's Alder reaction with mechanism. So addition of HBr to butadiene. So this is how we represent bond line representation of butadiene. I've told you this end point means CH2. Here it is CH. Here it is CH. And this is CH2. When we add HBr, okay, when we add HBr, we can get addition of HBr across only one double bond. See, only one double bond. So one H adds here, one Br adds here. So it becomes a 1,2 addition. According to Markovnikov's rule, negative part goes to that carbon atom with least number of hydrogen atoms. Here we have CH2, here we have CH. Therefore, Br goes to CH containing carbon atom, Br here, and H goes to CH2 containing carbon here. So, addition has occurred across carbon number 1 and carbon number 2. Therefore, we call it as 1,2 addition. But to our surprise, we have seen that along with 1,2 addition, we are going to have 1,4 addition. So what happened here? We had one H add here and another Br add here. See, H has added here and Br has added here. So when we number this 1, 2, 3, 4, we have seen addition across 1 and 4 carbon atoms. Therefore, it is called as 1,4 addition. And we can notice here 1,4 addition is a major product, whereas 1,2 addition is the minor product. Why is that so? To explain this, we need to look into the mechanism of addition of HBr to butadiene. What happens? You have to see here, you have to remember butadiene is an example of conjugated diene. Recall, conjugated dienes are dienes where the double bond is separated by only one sigma bond. Okay, butadiene is a conjugated diene. With that background, now let us move into addition of HBr. You need to remember Markovnikov's rule and classification of butadienes in order to understand this particular concept. So look at the mechanism here. So what happens is, I told you, in any electrophilic addition reaction, you have two steps. The first step is addition of electrophile and the second step is addition of nucleophile. Because this itself is a nucleophile, it cannot attract nucleophile first. It has to attract the electrophile. See, this double bond moves to H, attracts the H. So we have H binding to this. This is according to Markovnikov's rule. This is CH2, this is H. The proton or the positive part goes to that carbon atom with more number of hydrogen atoms. So hydrogen will get attached to this carbon atom. It has got attached here. Automatically this carbon atom becomes a positively charged carbocation. This is a positively charged carbocation. Now there will be an argument. Okay, see, this is a secondary carbocation. But when you have a double bond attached to a positive charge, there will be a resonance. You have learnt about this resonance. So hyperconjugation effect. Okay, in your first semester. So there will be a conjugation. This double bond is going to shift towards this positive charge. There will be a resonance hybrid. Okay, there will be a resonance first here with a shift in carbocation. See here, the carbocation here has shifted to carbocation here. What's the difference between these two carbocations? This is a secondary carbocation. This does have only one substituent, so this becomes a primary carbocation. So from secondary carbocation it has become primary carbocation via resonance. Okay. Now what happens is your Br minus can either attack this primary carbocation or Br minus can attack the secondary carbocation. If it attacks secondary carbocation, we will have 1,2 addition reaction. But when it attacks this primary carbocation here, we will have 1,4 addition. See, there will be a different products. There will be different products. But we have to remember 1,2 addition is less. Even though you can tell that this is secondary and it is more stable than primary, because of resonance effect. Because of resonance effect or conjugation effect, we are going to get 1,4 addition product as major product. Okay. So let us look at the mechanism once again. You have diene. The first step is attack of electrophile. The electrophile attacks either to this two carbons or this. Both cases you are going to get carbon at the end itself. Hydrogen at the end. So hydrogen attacks to the end carbon atom according to Markovnikov's rule. This is according to Markovnikov's rule. And then we have a secondary carbocation next in conjugation with a double bond. So there will be a resonance. This resonance is more stable and hence in the second step where nucleophile attacks, the nucleophile will predominantly attack this carbon atom, giving us 1,4 addition product as major product in comparison to 1,2 addition product. Okay, we have to consider Markovnikov's rule only in the first step. In the second step, you have to consider conjugation effect. Let us nomenclate this now. See here, 1, 2, 3, 4. This is a butane, but 1 has double bond and 3 has bromine. So it is 3 bromo, but, 1 ene. This is, see, you can label it from here. This double bond is in the center. Hence, you have to label such that substituent gets least number. So it is 1 bromo, but, 2 ene. 1 bromo, but, 2 ene. Okay. Let us move on to next part, that is Diel's Alder reaction. Diel's Alder reaction. Diel's Alder reaction is a concerted reaction. What are concerted reactions? Concerted reactions are reactions which occur in only one step. Single step reactions are called as concerted reactions. Here you have two things. One is a diene and another one is a dienophile. Diene we know, right? We have studied in this chapter dienes itself. Two double bonds are there. So this is a diene. This is a conjugated diene. A conjugated diene reacts with a dienophile. Anything which likes the diene is called as a dienophile. This is usually an alkene. Okay, alkene. Diene reacts with dienophile to give a cyclic product. To give a cyclic product. Such reactions are called as Diel's Alder reaction. There may be two ways of electron movement. See here, the first way, double bond shifts in between these two carbon atoms. Then this double bond shifts here and this double bond shifts here. You will have new bonds formed between carbon 1 and carbon 6 here. New bonds formed between carbon 4 and carbon 5. Okay, this way you can show. Or else you can show in the reverse way. So reverse way is like this. Double bond shifts between 1 and C. This bond shifts here and this bond shifts here. There will be new bond between 1, 6 and 5, 4. So totally in any way you show the reaction, you are going to get this one product. This product is cyclic with one double bond. So it is cyclohexene. Cyclohexene. Okay, you can show it either in clockwise flow of electrons or you can show in counterclockwise flow of electrons. Both give the same result. So what has happened here is you have two new sigma bonds. See here, these are two new sigma bonds and rearrangement of the pi bond. Such reactions are called as Diels-Alder reactions. So these are the references. In this session we have seen addition of HBr to butadiene with mechanism and Diels-Alder reaction. Thank you.